In flowcharts, we have rules that govern one when drawing flowcharts. A flowchart should contain one start and one end symbol. The symbols that we have start, we have end. It should have one starting point and one end point, because the program should be clearly stated with the proper beginning and the proper end point, which must either or be 1. It should be drawn clearly and neatly. This means that crossing of lines should be avoided to avoid ambiguous cases, and symbols should be drawn with exact shapes. We looked at shapes, therefore, if you at start, then you use this shape, the starting point or end point. If you want to read, then read a print using parallelogram. So start with oval, read or print with a parallelogram. Then if you have an assignment to carry out or to improve the program, use this rectangular shape. If you want to make a decision, all decisions must be made using this rhombus shape. Therefore, it should be as simple as possible for easy interpretation. The reader, when given this flowchart, must be simple for him or her in order to interpret what it's all about and what it is intended to solve. Only the standard symbols should be used. The standard symbols, as we have seen, should only be used. The assignment statements are denoted with the left arrow, showing the passing of the specified values or variables to the variable on the left. As I had said, that this arrow means they are the same. They mean that xn is replaced by xn plus 1, or xn now becomes xn plus 1. And clear it is here that xn plus 1 is declared to sit in variable xn. In other words, xn is replaced by xn plus 1. So when you are computing and you begin with xn and you make a decision whereby what you want you have not finally reached there, then you replace xn by xn plus 1. That means it is done after a decision has been made. Also, n is replaced by n plus 1. This is where we improve. You begin with, let's say, n as 1, and the output is not clearly coming out the way you want it. It means you improve n by 1, it becomes 2. That means the original n as 1, add 1 to get 2. And this means n plus 1 is declared as the value to sit in n. For instance, if you have a flowchart to solve quadratic equations whose roots are real, then you start, connect with this connecting line, then you read coefficients a, b, and c. After reading these coefficients, substitute them in the formula. So you can see, read a, b, c in the formula, which is rectangular. That means we have used a proper symbol. The formula, substitute. Now the question may be, or are values a, b, c read properly, or are values a, b, c going to give us roots which are real or roots which are complex? So that should be the decision. If no, then it means we have to go back and check whether they are properly read. So we go back. If their values are properly read and they are giving us real roots, then it means we command the system to print for us the roots. And if it is quadratic, we expect two roots. They may be real, equal, or real and distinct. Then the program stops. And therefore, these arrows must be properly written down in order to show the progress of the system. So these are the set of rules that must govern our flow charts, which we are about to draw. Now the flow chart, for instance, can be modified to get if you want all roots, both real roots and complex roots, then it means our program should be start, then read values. As we have said, you start the program or you start the question, read coefficients A, B, and C. Then this time we shall have a discriminant. B square minus 4AC is a discriminant. If this discriminant is less than 0, it means it is giving a negative value. Therefore, if a discriminant is less than 0 and it's giving a negative value, it means we are getting the square root of a negative, and we shall end up with complex roots. Therefore, this is the decision. Is the discriminant less than 0? That's the question. So you can see that's the decision you need to make, which has two outlets, a yes or a no. If it is less than 0, it means we shall get complex roots, and therefore we shall have roots x1 and x2 because these are plus or minus. We shall end up with two roots, and as no complex numbers, we shall see they are conjugate. One is a plus, a minus, and the process continues. Then the values of x1 and x2 as complex roots are printed or written down. Now, if the discriminant is not greater than 0, it means it is greater than 0. If it is greater or equal to 0 or greater than 0 whatsoever, it means our values will be real, and therefore shall print real roots x1 and x2, and therefore the program will stop. So that is how we can have a simple joined flow chart to compute or to solve a quadratic equation. Now you can also have a flow chart to convert temperature given in Fahrenheit or to Celsius. And you can see that this flow chart is what we call, it is a direct one, it is not a looped one. Because a looped one, we have to improve or keep on repeating steps. But here, the steps are not repeated, so it is, as we said about flow charts, this is a branched flow chart because it has only one branch, and after making a decision, print and stop. Now, this flow chart, which is to change from centigrade to Fahrenheit or from Fahrenheit to centigrade, it is a simple flow chart. As you can see, you simply start with, of course, C and F as 0, then you read F, because you want to change from Fahrenheit to centigrade, because F is known. So if F is possibly 32 degrees in Fahrenheit, then we shall see that to get C, we shall use the formula. As you can see, the symbol into 32 minus 32, and we shall have 0 degrees. Therefore, if C is 0, it will be written down, print C, and stop. So this is a simple flow chart. You want to look at how we can test and evaluate our algorithms and flow charts. And one way to test flow charts is to perform what we call a dry run. There is a word called dry run. A dry run involves drawing a trace table containing all the variables a flowchart contains. So when you were given a flowchart with algorithms or steps, then you draw a table that contains the variables in that flowchart, and whenever a variable changes, the change is indicated in that table or in that dry run. And by performing a dry run, then the purpose of the flowchart can be predicted, or what an algorithm is all about can be predicted. Now, we want to begin with flowcharts which are drawn, and we see how we can test the algorithm, or how we can state the purpose of these flowcharts. Can state the purpose or the relationship between the variables. And we want to begin with a flowchart. The question says, study the flowchart given and perform a dry run of the flowchart. State the relationship between M and N. And clearly, the flowchart, they want us begin with N as 0, K as 0, M as 0. So we shall draw a table. As you can see that in a flowchart you have got N that changes, so we can have N, M, and K, and we shall draw a table, and this table, our variables are K, M, and N, and they want us to start or begin with N as 0, K as 0, M as 0. Now you can see that N as 0 is replaced or is put in its place N plus 1. So increase N by 1 to get the new N. Therefore it will be 0 plus 1, and the new N will be 1. Now M will also change. At this level, M, the new M will be the original M, which will be 0 plus 6 times original K, which will be 0 plus 1, and M will be 1. Now K is replaced by K plus N. In other words, K was 0, therefore we shall have K plus N. And at this level, as you can see, the flow of a flow chart, at this level, N is 1 because N has changed from here by 1. So we shall have 0 plus 1 because K has not changed. So it changes here by K plus 1, and therefore K becomes 1. It is original K which you came up with as 0 plus the new N, because it changes here, it becomes 1. Then say print N and M. That's what I've done in our dry run, in our table, the trace table that shows the variables. Is N equal to 10? That is our decision. And you can see N is 1, not 10. So the answer is no. And you go back, increase N by 1. That means, but at this level N is 1, therefore increase by 1, it becomes 2. When N becomes 2, it means M will also change. And clearly, when M changes, it becomes M, which is 1, because at this level we have M as 1, plus 6 times 1, because K is 1, no longer 0, because here K has changed to 1, it becomes 7 plus 1, and we shall get 8. Now K will change, because here K will have 1, but N has changed to 2. Therefore, it will be 2 plus 1 and it becomes 3. Print n and m, that's what we have done in the table. Is n 10? No. So the process continues. Increase n by 1, it becomes 3. Then we are here. N, it was 2. Then plus 1. N has changed to 3. M must change. M here, we have 8. K, we have 3 plus 1. So it is 8 plus 6 times K. 6 times K plus 1. So when you compute M as 8 plus 6 times K, 6 times K, where K is 3, then plus 1, you will get the new value of M, and that one gives 27. Then K will change, because here K plus N, it will be K, 5, we have 3 plus new N, and we shall have 6. Now, from there, you keep on increasing N, 4, 5, 6, 7, 8, 9, 10, until you reach on N as 10 and stop. Now, is N equal to 10? No. Increase by 1, it becomes 4. When you put in the formula for M, M will give you 64. Then K will give you 10. Then you go back, N increase by 1, it becomes 5. Put the value of M when N is 5, 125. Then K becomes 15. N increased by 1, it becomes 6. Now new M will be 216. Then new K will be 21. Print N, what we've done is N 10, no, it is 6, no. Then increase N by 1 to become 7. Then when N is 7, we shall have M at 343. Then we shall have K as 28. Is N equal to 10? No. Increase it becomes 8. Then the new M becomes 572. Then K becomes 36. Is N equal to 10? No, it is 8. Then increase by 1, it becomes 9. When N is 9, M becomes 729. K becomes 45. Is N 10? No, N is 9. So go back, increase N by 1, it becomes 10. New N becomes 1000. Then new K becomes 55. Then we are here, print N and M, that we have done. Is N equal to 10? Yes. Stop. So the program stops. So this is a dry run that contains the contents of a flowchart. Can you see? It contains the contents of the flowchart. The flowchart has got a set of procedures, algorithms from one step to another, connected by arrows. It has the start, it has the stop or end, and this is the table. Now from the table, you can predict the relationship between N and M. N and M, you can see, and in mathematics, can see 2, 8, 3, 27. You can easily see that 4, 3, 2, when you tube them, you tube this, you tube, you will get M. In other words, the purpose of the flowchart is to compute. We have been computing and print, or we write. So we compute and write the tube root, of a number, or the tube and the tube of a number or a number and its cube, which is the best. A number like 2 and its cube, which is 8. A number and its cube. And you could say that n is equal to m power a third, or the cube root of m you get n. In other words, n cubed will give you m. When you cube n, you get m. So that is the purpose. So when you are thinking of writing the purpose, you think of square roots. You look at the connection. Factorial of numbers is one the factor of the other. Multiples, factors, reciprocals, cube roots, fourth roots, depending on the outcome of the values that we have gotten in the table. Now, that's how we perform a dry run, and from there, we want to give you a task, which is a flow chart. Study the flow chart below and perform a dry run for the flow chart for x equal to 54, y equal to 63, and state the purpose of the flow chart. So that's the flow chart which you can do following the procedures or the steps involved as you have been told or given in the first question. That is, you start with a equal to 0. You read x. Now x will be 54, y will be 63 in the so your dry run, we shall have x and y, because you can see we have variables x and y. Then we start with a as 0. So we have a, x and y as our variables. Therefore, you start with a 0, x 54, y 63, and the question is read x and y. X is 54, then y 63. Those values would be read. Is x even? For instance, is 54 even? Then it is clear that 54 is even, and therefore we shall have two roots. So here there is a no. Here there is a no. Then here there is a yes. So the question is x even? 54 is even. So you follow yes. Then it means the new x is divided by 2. The original x, is divided by 2 to get the new x. Therefore, x is replaced by x over 2, and 54 over 2, that will be 27. Then y becomes, this is clear, that y becomes 2y. Y becomes 2y. This is y equaling 2y. Y is equal to 2y. Y is equal to 2y. In other words, the new value of y will be the original y times 2. Like 62, 63, you multiply by 2, which becomes 126. That will be the new value of y in the table. Then they are telling you, you follow the arrows, then you go back. You are here. Is x even? Like, is 27 even? No. So x is no. The answer is no, because 27 is odd, not even. And a will now become the original a, which will be 0 plus y. And at this level, we have y as 126. Therefore, our a will be 126. 126. And therefore, x is reduced by 1. You can see the new x will replace the original x where the original x is reduced by 1 and it becomes 26, because 27 minus 1 you get 26. Reduce x by 1. Is x 0? For instance, is 26 0? No. So is x 0? So meaning that here we have a yes, then you have a no. So our flow chart, we have x equal to 0, we have a no, then a yes. If x is 0, then you follow yes. If x is not 0, then you follow no. Is x 0? For instance, 26 is 0? No. Therefore, 26 divided by 2, which will give you 13. There is nothing here. So x 13, then you go back. You move down. Is x, then y will be double y, will give 126. Because you follow the arrows, y will be 2 times y, which will be 2 times 126, and that becomes 252. Then this one is nothing according to the process. Then you move on. Is x even? No, because it is 13. No. Then you follow the steps as you can see until you finish, and you will realize the connection between x and y, and you will realize that x and y, when you get the final answer, print A. This one is the one that will help you